Okay, everyone, we can start. So, thanks for joining, and hope you're doing great. And yeah, so this week we will be discussing about the basics of ROS. Okay, so I hope you remember the things that we have discussed in the last week. Mainly, we just started with ROS, then discussed about the some of the ROS concepts. Then we have seen like how the connection is establishing by the nodes. Yeah, I think we already seen the computational graph. Then yeah, I think we already seen this, like how the nodes are getting connected with the help of ROS master. And yeah, so these things we have communicated already. I mean, I have communicated, and like the concepts like nodes, master, topics, messages we have discussed. Okay, we have more concept to discuss actually. I will do that later. So today I'm planning to start with the installation of ROS on your computer. Okay, so I mentioned that ROS is a software framework, or we can call it as a communication middleware, whatever it is. It can be installed on your Ubuntu machine. Okay, so um, I think I have shared the website of ROS, so you can simply go to ros.org, which is the official website of ROS, and then you can just go to the get started, and then you can able to see the installation. Okay, so I think I have shown to you, and I hope you have tried the installation. If the installation works good, then that's okay. Today what I'm planning to show you is like not the not showing the installation, but just explaining what is going on the installation. Okay, just explaining the steps. So basically, in our course, we will be focusing on ROS Neutic and ROS Foxy as a ROS 2 version. And so we are discussing the ROS 1. So let's start with ROS Neutic. Okay, so this is the latest version of ROS 1. This is the last version of ROS 1 as well. Okay, and you will get support of ROS 1 Neutic up to I think 2025. Okay, so you can safely use ROS Neutic. You will get updates and all. After that, also you will get you will you will not get I think updates, but these packages will be there. Okay. Okay, so in order to install ROS Neutic, you should need Ubuntu 20.04. Okay, so in order to understand that, I think you have you may have seen this. Just a sec. If you press this, yeah, I think they don't mention. Okay. So from here, if you press the installation, you can find the platform. Actually, there is a mistake they have done in the website. Actually, when we press the install button, it should go to the platform, not directly to the Ubuntu. It should go to this page. Okay, so then we can select the platform, like in which platform that you want to install ROS. Okay, so currently the full support is actually to Ubuntu and Debian. Debian is actually like a parent, and Ubuntu is like a child, right? Debian is releasing each year, only one release, and Ubuntu, I think after 6 months there will be a release. Okay, so here the complete support is for Ubuntu and Debian, and it will work with Windows. Okay, but I will not say it's fully supported, but a lot of features are there. Okay, and then some other Linux distribution. So we are going with Ubuntu and Ubuntu Focal, which is 20.04. Okay, it will be working with Debian as well. So Debian Buster, I think it's Debian 10. Okay, and this ROS Neutic distribution can be installed on AMD 64 base processor. Okay, AMD 64 means mostly you will have the 64-bit processor, so it will work. Then ARM HF 32-bit and ARM 64. So ARM64 is the Jetson Nano and all. Also Raspberry Pi. This is ARM 32 bit. That is also working. I mean, in some Raspberry Pi it's 32 bit. So these in this architecture it will work. And if you want to install Ubuntu, if you want to install ROS on Ubuntu Focal, just click it and you can see the installation. Okay, so maybe first when you go through the installation step, you may have some confusion what these steps about. Okay, so that's what I'm trying to explain. Okay, so here what we are basically doing in the installation is in the ROS server. Okay, so there is a server for keeping the ROS packages, Debian packages. So all these packages are in the ROS server. Okay, so somehow we have to download these packages and install it. Okay, that is a step that we are doing here. Okay, so there is a ROS packages that is placed in some ROS server. Okay, and you have to somehow download these packages and then you have to install using apt-get. So that is what we are doing. So in order to do this process, first what you have to do is you have to add the server address basically. Okay, I'm just saying in an abstract way, like there is a provision to add the package server. Here it is ROS package server to Ubuntu. Okay, so this step is actually doing it. There is a thing called sources.list. Okay, so into this file, into this list, basically we can add the ROS server. Okay, ROS server, the location of the ROS server. So it is packages.ros.org. Maybe you can, I think you can visit this website. Just a sec. Yeah, so this is the location. And if you check Ubuntu, you can find distribution, and you can go to the Focal, and you can see the main, and here you can see the packages. Okay, just a sec, maybe I can just paste it. So here you can find a binary for AMD64, ARM64, everything. Okay, so if you check AMD64, you can see the packages list and all. Okay, packages list. There are some some links and all. Okay, so this is what we are doing here. Okay, we are just adding the location to the sources.list, and there is a single line explanation. Set up your computer to accept software from package.ros.org. Okay, because in Ubuntu there is a provision to add the server address. Then Ubuntu will check on this server to get the packages. Okay, so we have to add the sources.list. Then we have to download the packages, right? We have to download. So in order to download these Debian packages in Ubuntu, we are using .deb extension as the package or installer. Like in Windows we have .exe file, right? So whenever we click the exe, it will show a setup a wizard, and you can install it, right? So in Ubuntu it is .deb file. Okay, you can simply click and install the application if it is a deb file. Okay, so all these deb files of ROS is actually in the packages.ros.org. Okay, so we have added it, and then in order to download it securely, we have to add a secure keys. Okay, so the secure keys is actually here. Okay, so if you just go here, there is a secure key. Okay, secure key. So you have to actually add the secure key to the apt package manager. Okay, then only you can securely download the packages from packages.ros.org. Okay, so in order to add, or in order to download these key, we need a tool called curl. Okay, I'm not sure you have heard about this tool called curl, which is basically for like fetching files. Yeah, it's a command line tool. Okay, we can do a lot of things using curl, but here it's basically like downloading this file, okay, and then adding as the key, okay, apt package and manager key. After that, you can able to download the packages of ROS. Okay, it's a binary package, meaning it's already built for your computer. Okay, for your computer means for AMD 64. Okay, so now it's just a matter of like installing these packages. So before installing the packages, we have to update the apt, we have to update the apt package list. Okay, I'm not sure you have idea, but in Ubuntu, I will recommend you to install a application. I think in our warming up section, I think I have mentioned it. There is a tool called Synaptic. Okay, Synaptic. Maybe I can just mention the command. This is a GUI version of apt package manager. So this is a Synaptic package manager which is showing the existing apt packages. Okay, so this is the list of packages that is currently available, and you can easily install it by double clicking it. Okay, so this much packages is available for free for us. Okay, so this is actually a list of packages, right? So after adding the sources.list and keys, you have to update this list. Okay, this list that we are seeing here. Okay, then only the apt will show the ROS packages on this list. Okay, I already did this thing. I already installed ROS. So if you just search about ROS in the package list, you can able to see a list of packages. Maybe I can just go down. Yeah, you can see here starting with ROS, these all are ROS packages. Okay, there are many packages. You can able to see, right? Oh, there are many. I'm not able to scroll. Yeah, so you can find starting from ROS, there are many packages. Okay, so these packages are coming from the ROS package server. Okay, which is the packages.ros.org. Okay, so after doing the updation, we will get all the ROS packages, and then we have an option to install ROS. So this is where we are installing ROS on your computer. Okay, so there you will get three options. Okay, first is like a full version. You can install almost all the packages of ROS. Okay, not everything, but like we can say like most of the important packages, including simulation, then perception, all those stuff. Okay, and this is what recommended. Okay, so if you're working with a laptop, I will recommend this this command. Okay, just a second. Let me see if there is any question. Okay, so I will recommend this command to install ROS. Okay. Yeah, so Kalpesh is having a question. Is it possible to increase the resolution of view? Yeah, of course. So can you able to see Kalpesh now? Kalpesh, can you able to see? I think it is. Oh, okay. So okay. I can also increase the stream resolution, but sometime it will create issue. Okay, maybe I can zoom it. Okay, so here you can able to find this command for installing ROS on your computer or your Raspberry Pi or your Jetson Nano. Okay, and the second option is if you don't want the simulation or perception, just some basic tools, okay, like some tools like RQT, RVs, and not like simulation or navigation perception, you can go with ROS Noetic desktop. Okay, so it will depend on your application. If you are into simulation, perception, lot of stuff, then desktop full will be your choice. Otherwise, desktop. Okay, so what is the difference? The main difference you get in each option is that one is like you don't need to install unwanted packages, so you can save space, especially when you work with some limited storage in Raspberry Pi or something like that. If you want to save space, you can just go with the exact packages. Okay, but if you have enough space, then obviously desktop full. Okay, and if you just want the core of ROS, that is a communication libraries. Okay, if you just want the basic part of ROS, you can simply go with ROS base, ROS Noetic, ROS base. Okay, so the ROS base is mainly using in Raspberry Pi, Jetson Nano and all, because in some scenario, if you want to build an application in ROS, you just need the ROS core part, just the communication part. Okay, then you can simply like install the specific packages you require. Okay, so there is a lot of difference between ROS base and desktop full, because it is taking a lot of space. It is taking, I mean, very small space, and you will get the ROS core part, that is a communication libraries. Okay, there is no tools and all, only like command line tools. Okay, so you can save space, and also you can make the complete storage. I mean, you don't need to use much space, and this is very useful while you working with Docker container. Okay, so you can deploy a ROS application using Docker container. So while playing with Docker, you have to, I mean, reduce the space, and you have to somehow execute your application. It doesn't matter like you install 10 packages or 10 unwanted packages or 20 unwanted packages. It doesn't matter, but the thing is, it's actually creating more space. It's using more space. So when you work with Docker based application, the one of the priority that you have to give is like use the base of ROS, then install the specific packages you require, so you can just create a very lightweight Docker container. That is also applicable for the SD card based storage. Like if you work with Raspberry Pi or Jetson Nano, okay, imagine, then you set up everything on Jetson Nano Raspberry Pi. Okay, you install your own application, and if you want to create a clone of your SD card, that is actually possible. You can entirely clone the SD card. Then also the space matter, right? So these things has to be considered. So based on your application, you can select. Okay, so in single board computer, we are mainly preferring ROS base. Okay, but if you have a lot of packages dependencies, then desktop full or desktop. Okay, so the installation is not finished yet. It will take time. This thing will take time. Okay, this is a main installation steps. Okay, you can only do one. Okay, either this or this. Okay, so after that, the documentation says, like after installing the main packages, you can selectively install the required packages. Okay, so if you want navigation, you can install navigation. If you want Gmapping or SLAM, you can install it. Okay, so there are tons of ROS packages, so you don't need everything, so you can selectively install directly. Okay, Yes, so there is a command like to search the packages as well, a command line tool. So you can use apt search rosneutic. You can find, so this is more convenient. You can find, so if you enter this command, you can able to find the entire packages that is starting with rosneutic. So you will get this much of packages. There are many packages actually. We can't see everything in the terminal, and you will get a short, yeah, a one line regarding the package as well. Okay, I think that will be useful. So after installing the ROS main packages on the PC, the next important step that you have to do is this command, these two commands. It's very, very important. Okay, don't forget, otherwise you will feel like you didn't install ROS or the installation didn't work well. Okay, so basically what happened after the installation is, so if I already installed ROS on my VMware, okay, it's already there. So when you install ROS on your computer, you can see the installation from the following folder, that is opt rosneutic. Okay, so this is actually the default installation location. Okay, you got it right, a slash opt rosneutic. So this is the location where ROS is getting installed. Okay, so once it install, it will install everything like the commands, everything, but you can't able to access the commands and everything from the terminal. Okay, like you can work with ROS from terminal, mostly from terminal. Okay, not from like from the GUI. Okay, so in order to make the ROS tools visible in the terminal, you have to execute this command. Okay, you have to execute this command. Okay, so what that does is that this command is basically the command. Okay, and I will explain. So what happening is that if you just go to this location, okay, opt rosneutic setup.bash, that is this file. Okay, so when you just execute it, okay, when you execute this shell script, okay, I already mentioned what is a shell script. So when you just execute this shell script, then you will get, I mean, you can able to see all the tools, all the commands from ROS. Okay, it's not just execution, it's sourcing. Okay, sourcing means the setup.bash is having lot of variables, lot of environment variables, lot of things. So that will be sourcing. Okay, sourcing means if you source it, the variables, environment variables and everything will be available on the terminal. Okay, so the sourcing means, for example, if you source this line in the terminal, you will not get anything, but the thing is it will be executed and all the environmental variables will be can be accessed from the terminal. Okay, so when you simply do this, you can able to see the ROS commands. Okay, so in order to make this sourcing permanent, what you can do is you can do this command. It's basically I mean, writing this line to .bashrc. Okay, I hope you know about the .bashrc, which is actually the configuration file of a bash shell. I mean, this is the terminal application which is based on bash, and if you just go to home, okay, I'm just increasing the size, and if you just execute gedit space bashrc, okay, this symbol I think you are familiar, it's just above the tab, okay, tab key, or just under the escape key. Okay, so if you just do this, you will get the configuration of the bash terminal. Okay, bash, and if you just go down, you can able to see this line. Okay, so this line. So basically what happening is when you execute this command, okay, this line is getting added to .bashrc. Okay, and then we are sourcing bashrc, meaning this bashrc is again a shell script. Okay, so we are sourcing it. So while sourcing, this will also source. Okay, so when you take any terminal, any new terminal, this .bashrc will be getting called. Okay, maybe I can show a demo. Like I'm just giving a echo command like hi Linton, okay, in .bashrc. Okay, so now I'm just saved and then I'm taking a new terminal here. So you can see hi Linton here. Okay, so that means whenever we take a new terminal, this guy, this bashrc is getting executed. Okay, so when you add a source line of rows in bashrc, what is getting executed? This will be getting executed. And what is the advantage? Then whenever you take a new terminal, you don't need to source again and again. You can able to see the rows command from any terminal. Okay, so in order to see the rows commands, okay, if you install like this, in order to see rows command, the perfect way is that just type ROS. Okay, and then press the tab key, keyboard tab key twice. Then you can see a lot of commands starting from rows. Okay, so these all commands are actually the part of rows installation. Okay, and these all are command line based rows tools. I already mentioned, already discussed about the rows equation. What it is having is like it is having the plumbing, which is the inter-process communication. Then the tools. Okay, tools can be graphical tools or command line tools. So these all are command line tools. Okay, and then the capabilities and ecosystem. Okay, so after getting these commands, you can assure that like your rows installation is working. And finally, if you just execute this command, which is rows core, maybe I can increase the font size. Just a sec. Monospace. Okay, so if you just if you just execute rows core, which will run, and you will get a message like this, which says that your rows installation is mostly okay. I mean, it's perfectly fine. Okay, so this is how you we can install rows on your computer. Okay, the manual steps, you can just do this. Okay, then the installation is finished, and then there are some more packages that you have to install, okay, which will help you to install dependencies and all. So just copy paste. Okay, just copy paste this command on in the terminal. Okay, so by the way, don't forget these things are executed in the terminal. Okay, like copy and paste into the terminal. Okay, you have to do like this. Okay, so simply copy paste this line, this two, this, and then desktop full or anything, then this line, okay, and then this line and this line and these two. Okay, after that the installation is finished. Okay, actually installation is finished from here itself, but if you have these packages, it will be good. Okay, you this thing called rows-dep, which is very useful to install the dependency. Okay, which is very useful while working with the rows project. You will get understand. Okay, so this is the rows installation, and I actually created a script, a one-line script to install one line script to install ROS, ROS Neutig. So when I got some time, yeah, so this is the video, and this is the script. Okay, and yeah, I thought like a one line will do the job. So what I did was I just created a video and a script. Okay, basically a shell script. Okay, it's not a big deal. So what you have to do is just copy paste this line, okay, into the terminal. Okay, then it will ask for the options, like yeah, first it is asking for the password. So I have given the password. Then it's automatically detecting the operating system and all, and it's doing the job, like the adding the keys, then updating the repository, I mean the apt list, and then yeah, it will take some time. Depends on your internet connection. So you can choose anything, like understand the steps of installation, then you can choose the one liner. Okay, so maybe I can share the installation blog. There is a video as well, so you will get understand easily. So the updation, so after this, let me see how is it going. Just a second. Yeah, and also if you want to uninstall, you can copy. So basically what happening is that there is a repository here. Okay, there is a repository. So the one-liner code does is that it will just download this script. Okay, so this is a script. Okay, shell script. And then after that, so you can see this one line is a combination of multiple commands. Okay, so in order to execute several commands in a single line, you can use this and. Okay, and symbol. So like this command is actually downloading the script. Okay, this is downloading the script. Then after downloading, it is changing the permission. Okay, this command is changing the permission to executable. Then this will execute. That's it. Okay, so that is the one-liner code. And here it is asking, the script is asking which installation you prefer. So one is desktop full, which is recommended, then desktop install ROS base. So I'm just pressing 1. Then it will just this is actually an updated package, but all the packages are installed, so it will not take time. So let's see. Let's wait for some time. Yeah, it's unpacking. Yeah. Yeah. So everything is done. Okay, everything is done. And then after installation, okay, after installation, even it is setting the bash.rc line. Okay, after installation, you can do the ROS version D. Okay, so this saying this will show the version of ROS. Okay, so if you are not getting in the terminal, take a new terminal and try. Okay, so this is the easier way to install ROS on your PC. Okay, so I just want to know how many of you tried to install ROS on your machine. How many of you tried, guys? Anyone try to install ROS on your machine? Okay. Okay. Okay, it's working good, right? Okay, great. Okay, Tarun also tried. I think Trushant also knows. Yeah, that's good actually. Okay, great. So I think we have installed ROS without any issues. Yeah, and do you have any confusion, guys, regarding the steps? Basically, what are we doing with the installation, the meaning of each step? Any confusion, guys? Nothing, right? Okay, it's easy. Nothing complicated. Okay, So we completed the installing rows section. We also seen the one-liner, which is for installing rows and uninstalling it. Okay. Now I just want to discuss about some more concept. The encoding styles IDE. I think that can be introduced maybe in the programming chapter. Regarding the file system, okay, that we can ignore. Yeah, maybe some more concepts. Okay, that will be good, and then we can play with the turtle sim to learn rows concepts. Okay, so let's start with some more concepts. Okay, it will not take much time. Maybe I can quickly go through it. Okay, so maybe I can visually teach you, like, so I hope you are clear with rows topic, rows messages, then nodes. Okay, so if you have any confusion in rows nodes, rows master, messages, topics, let me know now itself. Okay, so if you didn't attend the last session or something, you can ask if you have doubts. Then after finishing your doubts, I will be like jumping into other topics. So let me know if you have any confusion in nodes, master, then messages, topic. Yeah. Any confusion, guys? I mean, you can ask. Yeah, Kalpesh. Sure. No problem. Okay. So maybe I can start with the computation graph very quickly. So basically, the rows framework actually what gives to us is that it is having some functionalities, okay, which can be used to which can be used in our program, and using that functionality, you can make your program you can use that functionality to communicate with other programs. Okay, in this figure you can see these all are processes. Okay, these all are like programs that is running. Okay, so using rows, okay, rows is actually giving functions in order to communicate with different programs. Okay, so so when multiple programs are communicating with each other, it's basically forming this kind of structure called graph. Okay, so why we are going with multiple programs and why we need this inter-process communication, or like communication between multiple processes, is that in a complex robot, instead of writing everything in a single node or single program, you have to like write it in a separate program and then communicate with other programs. Okay, because that this will help us to debug the entire robot code. Okay, and you can also like find the bugs, okay, easily, and also writing code will be easier. Okay, so there are a lot of advantages in splitting the program like this and then communicating with each other. Okay, so I mean, when you start working on robot, you will understand the flexibility or like the real use why we are like writing multiple programs in a complex robot. Okay, because there are many sensors, there are many actuators, there are many applications in the robot. Okay, so each things will be doing by each programs, and then all the programs has to communicate and exchange data, send and receive. That is the communication. So it has to like send different types of data. Okay, so whenever these programs are communicating and then exchange data, it's basically forming this kind of graph. Okay, and rows is giving the APIs or functions to do this. Okay, so when we create nodes using rows, and when these nodes are communicating, basically it's forming a graph, and we call it as computational graph. Okay, and each process in the computational graph is called ROS nodes. Simply, basically, like if you create an application using ROS APIs, it will become a ROS node. Okay, so in the computation graph, it's basically showing like there will be multiple program, or like there will be one or two program, and it is communicating. So one node is here, one node is here. That's it. Okay, so that is ROS node. And so in order to communicate between two nodes or multiple node, there is another program called ROS master. Okay, this node is like a broker, okay, like marriage broker, you can say. So what this node does is that this is again a program running, and this is giving by, this node is actually giving by ROS. Okay, a ROS installation. You will get the master program from ROS itself. So master program is like whenever you run a ROS application, it will be first communicating to master. Okay, so the first program that you have to run in a ROS project is ROS master. Okay, so like I actually show you a command called ROS core, right? So ROS core is a command which is starting the ROS master. You can see auto starting new master. Okay, so you have to start the ROS master, then only you can start the nodes. Okay, so here it's showing a talker and listener example. So whenever we start any application using ROS, it should communicate it to master, and the master is the broker program which helps to identify two nodes. Okay, because here in this example, talker is sending some data, listener is like subscribing to that data. Subscribing means receiving the data. So there is a talker is sending the data, and listener want to receive the same data. Okay, so there is a match, and then master will like exchange the contact, like mobile number or something. Then they will start chatting. Okay, then they will send the they connected each other, and then they exchange data. Okay, but even though they connected each other, the master will be always there, because if there is a breakup happen, okay, that will also update it to the master. Okay, so master or ROS core command should be always there in order to like help the nodes to connect each other. Okay, so that is ROS master. Okay, and the next thing is ROS topic. Okay, so that is again a simple idea. Basically, like when one program want to communicate to another program, okay, they should establish a data bus or data channel internally. Okay, so then only program 2 can send a type of data to program 5. Okay, so the program 2, meaning the node that is going to send is what creating the data bus. Okay, so then after creating the data bus, the program 2 is sending the data through it. Then the program 5 is listening to that data bus. Okay, so the program 2 sending data to data bus, and that data bus is called ROS topic. Okay, ROS topic. ROS topic, for this data bus, there is a name associated with it. Okay, so ROS topic is like a named data bus. Maybe I can name this data bus as LinkedIn, and then I can send one type of data. Only a data bus can send one type of data. So you can assign maybe integer or float or like array or image or anything you can send. In order to send another type of data, you have to create another database. So you can create any number of data buses, and you can send data through it. Okay, so that is actually the ROS topic. It's basically a data bus. Okay, data bus which is creating by the publisher node, or the node that is going to send data, and the program 5 here, the example, is listening to the data bus, expecting the same data type. Okay, so that kind of data that is sending by the that is flowing through the ROS topic is ROS message. Okay, the data type. So here the ROS message is in 32, here is float 32. You got it, right? So that is the ROS message. Okay, so yeah, so these are the concepts we have discussed. I hope that is clear to you. Okay, Kalpesh, do you have any more confusion or something? Sure. Yeah. 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 Yeah, so that is actually done by the master. Like, so the program 2 is sending is creating a topic called Lentin, and it is sending a data type integer. Okay, so masters knows this. Okay, masters knows what program 2 is going to send, and then program 2 is expecting the same data type from the same ROS topic. So there is a match. Then master will exchange the detail, and then these two programs get connect each other. That's how it's working. Okay, okay, okay. So I talked about ROS topic. So the ROS topic, the kind of data sending from one node to another is like streaming data. Like program 2 is continuously sending these data, and then program 5 is listening to it. I can show you an example for that kind of communication. So I hope you already have seen it, but maybe the talker listener example. So first you have to start the ROS core, then you can start the node. So no need to worry about the command, we didn't discuss these things, but this is just a demo. So I'm running one node. Okay, and here I'm running the second node. So you can see the message that is printing here is the same here, and whenever I stop this message, this node, this will also like pause. Okay, so whenever I start this, this will also start. Okay, so I can show you the computational graph, the simple computational graph currently, and this is a computational graph. Okay, there is a talker node, there is a listener node, and by the way, you can name the node as well. When you create an application using ROS, you can also give a name. Okay, so this is the topic. You can name the topic, right? So chatter is the name of the topic, and the type of the data going through is string. Okay, so you can able to see that kind of data is maybe we can tap the data from the topic. So this is how we can tap it. No need to worry about the command. So this is the data flowing through that topic. Okay, so it's like streaming. Okay, it's continuously sending. So and there is no acknowledgement or something like that. There is no guarantee that the data coming from the publisher reach the subscriber. Okay, there can be data loss, by the way. Okay, in the sense, if you are sending these data over a network or something like that, there can be data loss. Okay, so this is kind of communication we are using commonly, but there are some other type of communication as well. Okay, like I can explain. This is ROS topic visualization. Okay, visualization means this is how ROS topic work. One node to another, continuously chatting, continuously sending. And this is how the ROS service work. Okay, ROS service, which is basically like a service, request response kind of communication. So there are two nodes, and one node is requesting to another node, and another node will process the request and send the response back. Okay, it's like a request response kind of communication, and it's not like rows topic. It will be like synchronous kind of communication. Okay, because there is an acknowledgement coming from the server. But one problem with this kind of communication is, once the client is sending a service request to the server, the client has to wait until the service request got finished. Here the example is like client is asking, client means a node. Okay, node is like sending a request 2 plus 2. Okay, so the server is having some like functions to execute it. So server will compute and then send the response back. Okay, so in the meantime client has to wait. Okay, so that is rows service, and which is very useful to trigger something like turn on and turn off kind of things can be easily implemented using row service. For example, if you want to switch on and switch off a bulb of a robot, you can simply use this, right? Because it's not blocking. The switching on and switching off is like turning on and turning off the GPIO. Okay, so that kind of things can be implemented using row service. Okay, so next thing, the last thing that I want to discuss is the rows action. Okay, so after this we can conclude. The rows action basically is a superset of row service basically. Okay, in rows action what happening is that and this is this communication is mostly using in rows for high level application. In rows action there is a client and server, so it's sending a request or goal, then server will send a feedback as well. Okay, the best example for rows action is the navigation stack in rows. So how that work is that we will send a goal position to the navigation stack. Okay, there is a node called move base inside the navigation stack. Okay, so what move base does is that it will receive the goal position from the client, and then it will send the robot to move to that goal position. Okay, so in the meantime it will keep on sending the feedback. Okay, and the biggest difference is that we actually given a goal position to the robot, and robot is going towards the goal position. Okay, and we are getting the feedback. So if you change our mind, like if you want to change the goal position of the robot, you can again give another goal position. So what happening is that this current task will be preempted, or it will be cancelled, and a new goal will be sending to the server. So this is very useful, like the capability of preempting or cancelling the existing goal and giving a new goal. Because if I give a task to the server and if it is taking a lot of time, I will just cancel it and give another goal, like that. Okay, so these are the three important communication things, communication types in rows: rows topics, rows service, and rows action. Okay, so rows action will take some time to implement, because it will take some time to understand. Okay, somewhat not very easy. Service is like in between rows topic and rows action. Service is again not very easy, but a little bit difficult than topic. Okay, topic is very easy to implement. Okay, so these are the communication types that we can use in rows. Okay, so tomorrow we can discuss the Hello World Turtle Sim, and then the programming. We can start with the programming, mainly the client libraries, rows packages, workspace, all those things. Okay, so let me know if you have any question, guys, regarding today's sessions and topics. Yeah, any question? Any questions? It's clear, right? Nothing complicated, I think. Okay, Okay, guys. So see you tomorrow, same time. We can discuss about the turtle sim and then come to the programming. Okay, which is one of the important part of ROS. Okay, we will start programming using the ROS communication. Okay, communication protocols like topics, services, those stuff. Okay. Okay, then see you tomorrow. Thanks for joining. Bye, everyone. Good night.